Something I see time and time again is a little bit of an underestimation of one's knowledge of their own process, perhaps, or to the extent by which manual ingenuity, operators' ingenuity, or their own just adaptability in the way that they approach problem solving is so intrinsic and essential to the process. You pull that out and, you come to find out that the process was perhaps not so well defined to begin with.
Yeah, you've got the process and then you've got the workaround. And the manager might know the process, but the rank and file employees know both the process and the workaround. And to the extent possible, you can't rely on the workarounds.
Exactly.
This podcast is for informational/entertainment purposes only and does not constitute professional advice. The views expressed in this podcast are solely those of the hosts/guests and do not necessarily reflect the official policy or position of Rockridge or its affiliates.
Welcome to the Automation Journey podcast, the place to go for lessons learned and insights to help you on your automation journey. I'm Colin. Mobile automation changes the safety conversation in ways that are not always obvious at the start. Most operations teams know how to manage people, equipment, traffic, and training in a traditional facility, but automated vehicles introduce a different set of questions. How should people work around equipment that moves without an operator? What changes when part of the floor becomes a restricted area? Where does the vendor's responsibility end and the operations responsibility begin? And once the applicable standards have been addressed, how does a facility know it is truly prepared to run safely? Today's guest is Pat Davison, Director of Standards at MHI, the largest material handling and supply chain association in North America. Pat has spent more than 2 decades working on the safety standards that shape how automated vehicles are designed, deployed, and operated, including involvement with the R1508 committee from its earliest days. What makes Pat's perspective especially valuable is that he is not here to advocate for one technology, one vendor, or one approach to automation. MHI serves both manual material handling manufacturers and mobile automation companies, giving Pat a standards-focused view of the industry as a whole and the safety questions buyers need to understand before automated vehicles enter their facilities. Pat, welcome to the Automation Journey. Thanks for coming on.
Thank you so much for having me.
Pat, you've spent much of your career with material handling standards. Can you give us a high-level, plain English explanation for what these standards entail?
Sure. Yeah, and let's start at the beginning. So a standard is a document that helps to define whether a product or a process does what it's supposed to do. That can include anything from minimum requirements for performance, operability, interoperability, operation, safety, materials of construction, whole variety of different things. They're accredited by either a national or international organization. For the United States, the national accrediting body is ANSI, the American National Standards Institute. And for international standards, at least in this area, we generally rely on ISO, or International Organization of Standardization Standards. And what standards are supposed to do are they're supposed to help facilitate trade and commerce by removing some of the barriers on questions or disputes on how things are supposed to work together, how safe is safe, if you have certain performance requirements, how those requirements are evaluated and established, and how they're reported. And all these things give both manufacturers, regulators, and users trust and confidence in making sure that everybody's speaking the same language. So when we're talking about material handling standards, it could be anything from automated vehicles to casters to racks to pallets even. You'll find that there tend to be standards for just about everything in the material handling space, and ultimately that's what standards are intended to help achieve.
Navigating the landscape of the different standards, certainly with respect to mobile automation, let's say, can be a bit challenging for someone embarking on their automation journey, in that you see that there's ANSI B56.5 that's relevant, also R1508 in some cases, and then many of our customers here are also looking to ISO 36914 for compliance there as well. Can you help our listeners understand where those respective standards are relevant, where the boundaries of them are, or in some cases where there might be some overlap?
So I mentioned both ANSI and ISO standards before. First, we'll distinguish that B56.5 and R1508 are American national standards, and then ISO 3691-4 obviously is an ISO standard. This is my personal opinion, but if somebody wanted to get very, very high level and discuss some of the major differences between national and international standards, national standards tend to pertain to the jurisdiction of the national boundary, in this case the United States, where they're produced. And ISO tends to take a little bit more of a holistic stand. ISO 3691-4 ultimately asks whether the autonomous mobile system is fundamentally engineered to be safe. And we can also get into, we're going to get into risk assessment, that discussion a bit later, so I'll hold off for that. But ANSI B56.5, on the other hand, asks whether the industrial vehicle is safely built, maintained, and controlled for the American workplace. And I like to think of American standards also as being a little more prescriptive. So B56.5 tells you some specific things on like how fast an AGV or an AMR can go, what the safe boundaries or safe distances might be, what accelerations, that type of thing. Whereas 3691-4 will get into a little bit more of that on a case-by-case or a risk assessment basis. Then R1508 imagines a scenario where you have an autonomous base and some sort of a mobile manipulator on top of that. When that standard first came to be, it was a bit of a marriage between two standards. It was the older version of B56.5, which was traditionally at that point just autonomous vehicles. And then the Robotic Industries Association R1506 standard, which gets into like a 6-axis industrial robot. Some things that all three of these have in common is that they are machinery standards, but this is a slightly unique type of machine in that it's also a vehicle. Machinery standards typically say that when some sort of a hazard is identified, the machine should come to a safe stop. And with vehicles, that's not always the right thing to do. Sometimes the safer motion will be to continue but avoid. So you could imagine like two AMRs or two AGVs coming toward each other, sensing each other, and then just coming to a stop. That doesn't really help anybody. So we've got to think of these both in terms of vehicle standards, like how does a vehicle move around a facility, move around its environment in a safe fashion? How does it avoid obstacles? How does it avoid other vehicles? How does it avoid people, poles, things in the road? But then when those things come to be, what is the machine to do? Another distinguishing characteristic is ISO 3691-4 and R1508 rely heavily on hazard identification and risk assessment, whereas B56.5, I like to think of it as having the risk assessment portion of the document already baked in and informing both the user and the manufacturer what to do in a typical operating environment where you might find these machines. So it tends to be a little more prescriptive in terms of identifying and mitigating hazards, whereas 3691-4 and R1508 tend to rely a little bit more on the risk assessment process to compel the risk assessment team to identify the hazards that might be present at a specific facility and then work to address those.
Pat, you had briefly touched on other machine standards just earlier, and I'm curious, in your view, How applicable are some of those other standards when you're talking about mobile automation, or would you consider that really in the case of ANSI B56.5 and the reference standards that are already baked into it, of which there are many? Do you view it as more like that's a thorough standalone document, and the document itself as well as the reference standards consider all of the real possibilities for compliance that an end user, manufacturer and end user should concern themselves with? Or are there yet other standards, other machine standards that also come into play?
A challenging question. And the analogy I sometimes like to use is if you're an accountant and you're looking at depreciation, there are a whole bunch of different ways to depreciate an asset. The best thing to do is to pick an approach and stay with it. So if you are a facility, perhaps a standalone facility in the United States, and your safety program is built around American national standards for some of the other machinery in your facility, well, then it might make sense to say that we are going to adopt and utilize B56.5 as our method for assuring liability, helping to identify hazards, and ultimately trying to mitigate risk. If, however, you've got multinational machinery, many of the equipment manufacturers in this space might be represented by U.S. Subsidiaries of international companies, or companies might have an international presence. They might be Mexico, Canada, South America, Asia, Europe, and they might want to have consistency throughout their enterprise, which might mean that they'll choose to identify or utilize international standards in their scheme or in their internal processes. Basically, either one of them are going to be fine. Both of those will have some normative references, and that essentially means that in the case of B56.5, if you're going to adopt those, the B56.5 standard, it's going to reference some other standards, which kind of draws that into account as well. And then ISO standards, almost by design, reference a whole variety of different standards, like the 3691-4 gets into a separate standard for risk assessment and separate standards for identifying your protective guarding, any user integrator, the team's going to have to be aware of all those different things. So short answer is yes. Slightly longer answer is it ultimately depends on the operations intent, strategy, and some other things that they're going to have to decide for themselves.
A lot of great insights already right out of the gate. I'd like to talk a little bit about your background, Pat, and your experience currently, having worked with MHI for some time, and your responsibilities really in spanning across both manual material handling solutions and automation. So with your perspective and experience, how do you see that transition going from a manual material handling world to an automated material handling world? Love to hear some of your insights.
Yeah, get comfortable. There's a lot of different things to cover here. So I want to talk just a little bit about MHI for those who might not be aware. We are a trade association. Traditionally, it stands for Material Handling Industry, and we have some 1,100 member companies that represent a huge variety of manufacturers in the material handling space. So that can go from anywhere to automated or manual equipment moving manufacturers, storage racks, conveyors, right down into packaging, labeling, anything that you might see in warehousing or distribution. MHI is almost that go-to place for members to learn, to connect, for market access, and for a whole host of other reasons. We also like to talk about what material handling is by use of winnowing it down to 4 separate pillars. So you can think of material handling as movement, storage, control, and protection of goods throughout their life cycle. Through raw materials acquisition, production, distribution, use, and ultimately disposal. So going back to your question, what do we see as the shift toward mobile automation? And even before that, you've talked about the fact that I've been in the industry for a while, and the gray hair might show that a little bit. My first ProMat show was in 2011. And as you're aware, we just completed the Modex show in 2026. And I think the shows are reflective of some of the changes that we're seeing in the industry. And in 2011, 2012 was a bit of a pivotal time in the material handling space as it pertains to automation. So people who might remember way back in the day, when Kiva, a small AMR company, was bought by Amazon in 2012, that seemed to trigger or send a notice to the industry that warehouse or a material handling automation could really start to become a thing. And sure enough, I looked up some market data, and it looks like the AMR market, just for an example, autonomous mobile robot market, has expanded from about $500 million or $1 billion in revenue in the United States in 2011 to more than $10 billion in 2026. And if you were at ProMat in 2011 and Modex in 2026, one of the huge differences you'd see is that our show floor is now has several different automation suppliers or providers. You see a whole lot more stuff moving on the show floor, and that's, I think, reflective of the growth in the industry, or the growth in potential of AMRs really over about the past 15 years or so, to just coming to be into fruition, into where we are now, where the market has expanded. But all that to say, the AMR, or the automation market, is still quite a bit smaller than the fork truck market. So we're at about 10 billion roughly in the automation space, and I think we're still like in the area of 70 or 80 billion in the forklift space. So perhaps you might know better. My crystal ball hasn't been working lately. Who knows where how the trends are going to continue on. But a few trends that we are aware of that I think are also working toward this is that forklift accidents are a thing, and that's almost baked into the equation. This is something that we're aware of. I was at the Warehouse Engineering Research Council conference a few years ago and sat in on a safety session. So this is practitioners in the space. And pretty much the whole hour was dominated by how do we prevent forklift accidents from occurring. So we know that this is an area where where we're familiar, and also we know that physically demanding in-person jobs are hard to fill. And with the aging workforce, we're seeing more and more people retire out of the workforce, people who might have been forklift drivers, and having a hard time filling those jobs. So we want to be agnostic, but reflect market trends. Not to say do one, not the other, but be more reflective of both. And if I can throw one more thing in there as well, there's something called Moravec's paradox, which I think is really important in the automation space. And it says that there are things that people or animals can do easily that are really, really hard for machines to do, and vice versa. There are things that machines can do really easily that are really, really hard for people to do. So, for example, if we were in the same space and I threw a tennis ball at you, you could catch it probably pretty easily. I don't have much of a strong arm.
Underhand, please.
But yeah, underhand, definitely. But teaching a robot or a machine to do that is exceptionally, exceptionally difficult. You might see, just coming into be or coming into the world, robots playing ping pong or something. Extremely hard for them to do that. Give a 5-year-old a ping pong paddle and a ball, they'll figure it out. But conversely, asking a person to do the same repetitive task 40 hours a week every day, or to do long division in their head, or to remember a sequence of 150 different tasks, or whatever. Extremely hard for people to do. Very easy for machines to do. So why do I bring all that up? Forklifts are driven by people. There are things that people do really well. I foresee a future where we probably won't get to that true full-on lights out warehouse. There will always be those operations where people need to be present, people need to be in the loop. And having the flexibility that a person with a machine can provide is always something that's going to be needed. However, there are going to be more and more opportunities for automation as the automation continues to improve, as the price point continues to come down, as people become familiar with knowing how to use these things, and ultimately as the workforce or our surrounding environments continue to change, and the economics and the ROI justifications continue to be a thing. So, again, MHI, we're not here to pick winners or losers, but we're here to acknowledge the broader material handling market and talk about comparative advantages and disadvantages across the entire space.
Stay tuned for more of the automation journey after this word about Rockridge. Is your company experiencing an impact on productivity due to labor challenges? Rockridge has partnered with companies in numerous industries, and we've helped them address their challenges. Many of our customers have seen measurable improvements in as little as 30 days from go live. This provides the freedom to assign human operators to the tasks humans do best and leaves the robot work for robots. Find links to contact us in the description or email info@rockridge.com today. Rockridge is your mobile automation team in North America.
Do you feel that there's inevitability to the transition from manual material handling to automated material handling in a similar way? Is it fair to draw a parallel to that with, say, the electrification that we've seen of manual material handling over the past few decades?
Is it inevitable? I think it will continue to grow, or as we continue to see options available, just in order for an enterprise to stay competitive, that's going to need to be a thing. It would be really, really hard to run a huge operation on paper, with a group of people scurrying around with carts or dollies, trying to meet order fulfillment obligations when another distribution center in the same market is able to do things a whole lot faster and a whole lot cheaper. So there does tend to be an inevitability in that, much the same way that, say, the personal computer decimated the typing pool. We're going to continue to see technology enhancing the workspace, helping to expand availability, helping to meet consumer demand. But yeah, I mean, all of these things over time will continue to, they probably will. There will be some degree of inevitability associated with that. I would agree.
I'd like to talk about the end user experience a little bit. So, when a facility transitions a process from manual material handling to automated material handling, what might come as a surprise to operations? Might not be expected?
I'll start that by talking about how I got into automation in the first place. I didn't wake up one day and say I'm going to be, some sort of a figurehead in the automation space. I started my career in environmental consulting, and after getting rained and snowed on for 10 years, I thought I might like an indoor job. And I wound up going to work for one of the big industrial robot manufacturers. This was in the late 90s. And they had just implemented an ERP system. So as you recall, back in that time, this is when companies were just really starting to adopt more of an enterprise-wide accounting and procurement system for their operations. So they're very happy to have this, but there were some inevitable hiccups along the way. And one of the hiccups that they had was that their vendors weren't getting paid. And the reason their vendors weren't getting paid was due in part because several of the items that the vendors were supplying weren't coming through the loading dock. And as them not coming through the loading dock, they weren't getting received into the system. The physical asset was being received, but it might have been drop shipped by an employee or picked up by somebody else, what have you. But the ERP system never saw that the item or that the order was fulfilled. And then 90 days later, this vendor was wondering why they haven't gotten paid. And turns out that the reason they hadn't gotten paid was the system never saw the item as the order being fulfilled. So why do I bring that up? I bring that up because automation relies really heavily on processes. And if you go from a manual type organization to an automated system, you're really going to have to understand and define what those processes are, train your employees on how to utilize those processes, understand what the pitfalls or ramifications could be associated with not knowing what those processes are, and then flagging some of the problems that could arise along the way, so that you don't get to that point where several weeks or months later you can't figure out why something that you thought was addressed quite a while ago wasn't done. So we could certainly talk about other examples as well, but that's probably a pretty important first part.
Something you see.
Automation relies on processes, and part of the challenge in the material handling space is it's hard to define processes, right? I talked to a major logistics provider several years ago, and they said their number one deterrent for not automating more of their stuff is they never knew what the next item they were going to get was. And they didn't know if it was going to be an envelope, a pair of skis, a truck tire. Didn't know the size, shape, weight, fragility. Does it need to stay hot? Does it need to stay cold? Is it perishable? They know none of this, so it's really hard to automate any sort of process unless you can really discreetly identify what those processes are.
Yeah, absolutely. And something I see time and time again is a little bit of an underestimation of one's knowledge of their own process, perhaps, or to the extent by which manual operators' ingenuity, or their own just adaptability in the way that they approach problem solving is so intrinsic and essential to the process. You pull that out, and you come to find out that the process was perhaps not so well defined to begin with.
Yeah, you've got the process, and then you've got the workaround. And the manager might know the process, but the rank and file employees know both the process and the workaround. And to the extent possible, you can't rely on the workarounds.
Exactly. when we were chatting earlier before the call here, you had mentioned that there's a difference between being compliant with standards and having safe operation. Can you expand on that, please, for the listeners?
Yeah, and let me clarify on that a bit, because it might sound counterintuitive coming from someone like me to say something like that. But ultimately, it is rare for an object or for some sort of a process that complies with its standards to be involved in a safety incident. But often it's not quite enough. And just to put a slightly finer point on that, many years ago, several decades ago, the Robotic Industries Association, in conjunction with the R1506 standard, did an evaluation of some of the industrial robot related safety incidents they could find, and did a comparison of what they were able to learn about the incident, and then compare that to or look into whether that incident was somehow addressed in the standard. And in just about every case it was. So the typical areas of concern got into things like control of hazardous energy, or lockout tagout, perimeter safeguarding issues. There's a case someone else told me about where there was the process and the workaround, and literally there was somebody who there was a part that would get jammed several times a day, and the workaround for somebody was they devised a little hand tool. They walked around the perimeter guarding and unjammed the device with their little hand tool. So, again, not great, but it kept the enterprise afloat. Or then span of control. And what that means is you see a very large integrated process. Everything's come to a halt. You want to get in and figure out where the jammed area is and get things back into shape. It can be really difficult in an automated system like that to identify that one area where it looks like there could be several areas. Or you could have a situation where if that one item is removed, the whole system jumps back into life. And that can be extremely dangerous if you have several technicians within a guarded area, or perhaps in compromised positions. So and the good news is just about every standard, I can't think of a single standard that doesn't address those issues. So those types of things are addressed. And be it a prescriptive standard, or an American national standard, or through the work of a well-done risk assessment, you'll probably get there. But the part that's not enough is we've got the machinery and the biology. The machinery is often predictable, and the biology sometimes is not. So in conjunction with changing your enterprise, any sort of organization is going to develop its culture, and psychologists or HR professionals will tell you that changing a culture can be a slow and difficult process. And creating a culture of safety, even in a situation where you want to make sure that you're still keeping the line moving, you're keeping things moving, you're meeting your demands, you're meeting your quotas. It's a really tough act, or it's a tough juggling act. So ultimately, for safety to really hit, you need both the compliance with the standards and the buy-in from the people, that that there's trust in the organization, there's see something, say something type approach, a
safety culture.
A safety culture, yeah. I also work with the Rack Manufacturers Institute. Rack damage, rack collapse is something that's potentially a huge issue. And frontline employees might have a reluctance to say, hey, I've seen a damaged storage rack column. We should take this thing out of service, for fear of if that person who's reporting that is a fork truck driver who might or might not have caused that damage in the first place. There can be fear of repercussion. So working to develop that safety culture across the enterprise is a challenge beyond just the standards compliance issue.
Really interesting. When deploying mobile automation, how should a buyer assess the division of responsibilities, say between the manufacturer and integrator and the end user themselves with respect to compliance and their responsibilities for safety? And do you often see confusion in how those divisions of responsibilities are interpreted or understood?
Yeah, a lot of my time is spent working primarily with manufacturers. So the way we go about developing standards in most of our cases is the MHI industry groups. So the rack or storage, or these people are comprised of manufacturers of those products, and they're the ones who are providing some of the day-to-day input on the content of the standards. So I tend to hear more from them about some of the problems that they're seeing. But certainly one of the challenges they have is not having a good level of understanding of the activities that are taking place at the enterprise. There are some of our manufacturers who work through distributors. So when they're building their widget, they have ultimately no idea how that widget's going to be utilized. Is it going to be in an auto manufacturing facility? Is it going to be at a smaller 3PL? Is it going to be part of a huge, highly automated warehouse distribution system? So certainly one of the things that they see as a challenge is their customer base coming back to them and saying, well, prescribe our safety for us, or where's the risk assessment with your product? And them coming back and saying, I can't do this because I don't know how you're going to use our product. So and ultimately, risk assessment, to the whole, one of the core tenets about it is collaboration amongst the various manufacturers involved in the broader system, the integrator, and the enterprise, and not just the management or the EHS folks in the enterprise, but also those frontline workers as well. Maintenance people, again, are wildly important in this aspect as well, because they're the ones who are really going to know the ins and outs of how things perform, how well they perform, how often they require maintenance. Is the maintenance more routine, or is it due to wear and tear? What does that wear and tear look like? Could it be prevented? All of these things contribute to potentially needing to get away from discrete and prescribed rules and working a little bit more in a partnership or in a collaborative environment. And I think there are quite a few companies who are doing that, but not doing that and trying to bring in automation is going to be tricky. So that might take just a difference in the way in which you go about your day-to-day business. Those changes are going to need to occur as well.
Yeah, the risk assessment component of putting together, working on an automation project, deploying automation can be a stressful aspect, right? What are some things that end users of those who are deploying systems in their facilities can do to approach that more confidently, the risk assessment process more confidently, and in general, what would just make a better risk assessment in your opinion?
Well, one, assemble the team. Two, understand what the process is. And I don't think, I might not have mentioned this quite yet, but when I talk about safety or when I talk about risk assessment, I often like to distinguish between the nouns and the verbs. So the nouns are the things that we see. They're the ones who tend to get all the attention. The verbs are the actions that those things that we see are doing. And I tend to be of the opinion that risk assessment is more about the verbs. So it's more about the action. Well, first identifying, again, the task and the hazards associated with that. So the task is the verb. The task might be get a pallet of fruit off a truck and move it into cold storage. You've got a number of different ways that you can go about doing that. What are the methods that the enterprise is going to utilize? And then what are the associated hazards with those? And the hazard part, this is another tricky area I see as well, because the hazard evaluation assumes that there are no guarding, there's no safeguards in place, and it pretty much assumes the worst case scenario. And the worst case scenario in a lot of industrial or material handling applications isn't so great for the individual. And our folks don't like to say the potential for serious injury or fatality is real if we don't do something about this. The whole idea is that we are wanting to do something about this. But I think there tends to be a bit of reluctance in admitting that if we don't do things right, serious incidences can occur. But that we're working on doing those things right so that hopefully those things don't occur. So identifying the verbs, identifying the hazards, saying this could be bad, and then NIOSH, the National Institute of Occupational Safety and Health, has a hierarchy of risk reduction measures that they prescribe, and they hit upon a couple of discrete areas. So first, elimination or substitution of the task, not necessarily of the equipment or of anything, but or the thing that is causing the hazard in the first place. So in the example of moving a pallet of produce from a truck to cold storage, is there a way that we could eliminate that move? Well, probably not. Is there something that we could do to substitute it? Again, probably not. But to the extent that there's a way that we can eliminate that task from being necessary to do in the enterprise, it needs to be done. Then we look at the exposure pathway. So if we have a hazardous object and we have something that's going to endure the effect of a hazard, so a person, and then we've got the pathway between those. And if we've got a bad situation where all three of those hit, we've got trouble on our hands. So what can we then do to mitigate the exposure pathway? And that gets into our guarding, light curtains, safety sensors, interlocks, fences, gates, all that type of thing. And then we talk about what do the people in the enterprise need to know about. So training, identification of safe work practices, signs, not necessarily protective barriers, but more lines in the road or awareness markings that say let's keep something here and something here, and this is our line of demarcation between them, and then respecting those lines of demarcation. And then ultimately PPE, personal protective equipment. So do we need to wear steel-toed boots, gloves, hats, safety glasses, hard hats, whatever it is, and ultimately being aware that a risk assessment or identifying those risk reduction measures is not just pick one from the menu, but it's often pick several and make sure that those integrate well together, so that if, for example, you have an interlocked gate with around a perimeter zone or a protected area, a person doesn't walk into the gate, close the gate so that the interlock closes and the operation can start back up. So you've got the safeguard, and then you've got the administrative control, the training saying, respect the guard. So ultimately, risk assessment, and it is broad and it's sort of all encompassing, but there is a procedure, there is a process to that. And when it's done well, it really can be an effective tool, but it does need to be administered and done properly. So knowing what you're getting into in advance, knowing your processes, knowing your procedures, knowing your verbs, and then working the process and sticking with the process and changing things, or identifying things along the way and making revisions, making tweaks. That's all part of the process.
Stay tuned for more of the automation journey after this word about Rockridge. Is your company experiencing an impact on productivity due to labor challenges? Rockridge has partnered with companies in numerous industries, and we've helped them address their challenges. Many of our customers have seen measurable improvements in as little as 30 days from go live. This provides the freedom to assign human operators to the tasks humans do best and leaves the robot work for robots. Find links to contact us in the description or email info@rockridge.com today. Rockridge is your mobile automation team in North America.
When deploying mobile automation, you had talked about the pathway just a bit earlier, and along that pathway, in the case of mobile automation, it could be a normal operating environment, or you could find it yourself due to space constraints or other reasons in a hazard zone or potentially a restricted zone. And I think you spoke to this actually quite a bit just now. Very interesting. But I'm curious. If we could drill in a little bit deeper on what does it actually mean for an end user to adopt a hazard zone in their environment, say along in an area where they may have pedestrians also coexisting with mobile automation, and how does that differ from how the standards define a restricted zone? Comparing, contrasting the two a little bit, and also what would be the approach to maintaining safety with either of those zones?
People walk downtown all the time. And I think we intrinsically acknowledge that sidewalks are for people and roads are for vehicles. But ultimately, people do need to access or get around, or ultimately just being aware and respectful of I guess I'd call that a hierarchy. Saying that person, be aware of your surroundings, be cognizant that there could be mobile automation coming through here. Avoid the space if possible. Don't loiter or congregate in the space. Don't leave things behind if you're in the space, but go in, do what you need to do, and get out and be aware of that space when you're there. Again, it's not, in my mind, it's not that much different from the outside or the built world. People know how to navigate this stuff, and I think they'll ultimately be familiar with it. Just bringing it into the facility, into the enterprise, might be a little different, but I think trust your people, train them, trust them, make sure they're encourage them to do the right thing. That ought to do the trick.
Yeah, I like that order: train, then trust. Not necessarily trust then train, but train first, then trust.
Yeah, train then trust. Yeah,
absolutely. Functional safety is a term that we hear every so often, but I think it's one that may not be thoroughly understood. So with respect to mobile automation, Where does functional safety come into play, and where do you see some misunderstanding about the limits of the functional safety and the overall safety ecosystem?
When I think about when functional safety was first described to me, I was thinking of being in a kitchen, sort of a, noisy, I've got some friends over, some other things going on, different stuff on the stove, maybe music's on, maybe there's a game on TV, whatever. There's a lot of activity. And I'm doing my thing and I touch a hot handle, or I'm chopping onions and I catch my fingertip or whatever. What do I do in that moment? I don't finish my sentence. I don't, continue to, wait for my friend to finish their story. There's a quick, immediate reaction to the hazardous situation that is effectively operated in another part of my brain that tells me this is not good. Get yourself to a safe state right away and deploy, get away, let go. Functional safety ultimately is the same thing in a machine. So you can think of it as a second brain in a machine. You've got the one brain taking care of all the operational signaling, when do I start a cycle? What do I look for when the cycle is there? Where do I go? Where do I not go? When is my cycle complete? What happens when it's complete? And then you have this other brain, another safety PLC with a series of sensors associated with it, just asking a couple of basic questions like, are we working? Is this safe? Are we working? Is this safe? Are we detecting anything? Is everything good? Functional safety talks about how you develop that other brain, so to speak. Added a little more to it, we want to make sure that other brain is not getting encumbered with a whole bunch of other tasks, a whole bunch of other things. It's doing relatively simple tasks very predictably, very quickly, very accurately, and can say, oh, something's not right. I need to send ourselves to an area where I can get to a safe space and then shut myself down and alert that something's not right. So functional safety is described in ISO 13849-1, and it gets into the architecture and the performance of that PLC and its components. It's a high hurdle to cover. Like I said, the components have to be tested to be very durable, very accurate, usually exceeding the life expectancy of the machine itself. And then they need to be very reliable. So often there's redundancy in and two channels going to a sensor, not just one. And then those channels, making sure that they're both in agreement with each other, that they're monitoring themselves, that the channel is working properly and the channel isn't picking up anything wrong. So in a physics for poets type answer to that, that's what functional safety encompasses. A couple of areas that people do it wrong. Functional safety also has different performance levels or structure categories, and they go from A to E. So A being the lowest, E being the highest. Well, any enterprise would say, well, we want to be as safe as possible, so we want to build everything to a performance level E. In many cases, you don't need to do that. Like performance level E was probably intended for the most hazardous of hazardous applications. And as an example, the industrial robot standard R1506 defaults to performance level D, structure category 3. And basically an accident with a machine that that requires a performance level D, I mean, it's still a pretty severe accident potential. It could result in a hospitalization. And then there could be enterprise or less hazardous areas where a lower safety category is warranted. So, understanding what those categories are, what they mean, how they're intended, and how they're used could help prevent you from over-engineering a system. And then finally, performing safety functions in a PLC or in a system that's not safety rated is something that a lot of practitioners in this space see a lot. So that's another thing to be aware of.
Pat, attention that you had raised before is that standards do tend to lag behind the technology 5 to 10 years. So curious, what are things that good manufacturers or diligent end users who are seeking to, or integrators who are looking to deploy automation, what are things that they should take into consider with their products and solutions that the standards may not yet cover today?
There's a couple of things that come to mind on this. An enterprise taking on some sort of a innovative technology in a state where the standard for that technology isn't fully published or adopted means that the enterprise could be taking on a bit of risk. So, what does that mean for the enterprise? It probably means that you want to take some caution. You might want to take things slowly. You might want to do some test cases, do some alpha beta testing, limiting the deployment right away to areas where you've deemed that you perceive the risk for something to be fairly low. Again, an area that I had seen this personally was I had joined the Robotic Industries Association in 2011, and this was right about the time when power and force limited robots were coming to be. The world knows these as cobots, but standards geeks like me call them power and force limiting robots. But these are the robots that we see that are designed or intended to work alongside a person, that have the extra sensors in them that will give way if object detection occurs. We saw these things being deployed while we were still working on the technical specification for deploying them. But we saw them being deployed in limited applications, in limited scopes. And another area that I haven't talked about yet is when we're talking about a standard for a specific technology, we call that a Type C standard, so C Charlie. Type C standards often rely on Type B standards, which might be standards for general industrial safety. And somebody can certainly rely on applicable portions of a Type B standard if they are deploying something for which a standard doesn't have specific coverage yet. And actually, the standard for risk assessment is known as a Type B standard. So it can apply across several different industry sectors. So, so certainly one thing that you can do is still conduct your risk assessment. Still, if you utilize industrial safeguarding or protective guarding, you'll rely upon the standards for safeguarding as a means to keep people safe. Still remember the administrative controls and PPE. So the train then trust. Do all those things. And One other plug I'm going to put in is if you're really interested, get involved with the standards development process. Something that I'm currently struggling with quite a bit is the people that I've been relying on for many, many years are retiring and leaving the workforce. Some of them are still engaged in standards development activities, but we really do need that next generation of folks to step up and help us work to develop those next generation standards. A couple of advantages to the organization is you get to shape and influence the content of the standards, and then you also get kind of a behind the scenes peek at the content of the standards, so that you can help direct your enterprise or direct your process in a way that will conform to the standard once the standard is published.
Do you consider there to be certain technologies or solutions that are commercially available today that may be in particular, where standards may be lagging in particular, that are, say, way ahead of the curve, maybe 5-10 years, that our listeners should be perhaps a little bit more, they just doing a little bit more diligence in terms of adopting and exploring?
The things that we're hearing in terms of AI and blockchain and that type of thing, like, those cats have left the bag. And there are ISO committees struggling to scamper to keep up. There are some other areas in terms of application spaces, things like digital wallets, digital identification, some of the sustainability initiatives that we might be seeing coming out of Europe. So having that full supply chain traceability of products in the marketplace, so knowing where the product has been, what it's comprised of, where those components have come from. Are they coming from areas in the world where there might be economic sanctions, or were they done in areas where there might be child labor or some things that the developed world deems unsuitable. So there's a growing field of requirements or mandates for those types of things, and there are standards development organizations scampering to try to put the processes in place to do that. I don't know that those things tend to affect the inner four walls of the warehousing or distribution space. But those are application areas or examples of spaces where there's a demand, either consumer demand or regulatory demand for certain information or for certain applications to occur, but where there are where standards are lagging.
Pat, what would you say to the listener who has adopted mobile automation technology, and let's say the standards have caught up with what they've deployed now? It didn't exist before, but now it does. Do they have the responsibility to verse themselves in the standards and ensure that they are up to date with all aspects? Or what should this listener do?
Many years ago, I had a colleague sit behind me, and she heard me on the phone all the time. I'd get a lot of questions from people, questions such as the one you just asked, which is a really good one. And after I got off the phone with somebody, she said, "Pat, you answer every question with 'it depends.'" So, so I'm going to answer your question with "it depends." The underlying guidance for compliance to a standard, well, first, in most applications, or in many cases, it's voluntary, unless there's a contractual obligation or there's a regulatory requirement to comply with the standard. But then there's also a grandfathering, if you will. Again, the analogy I like to use there is if you have a 68 Mustang, you don't have to put anti-lock brakes or an airbag in it unless you want to. But getting back to your question, the typical guidance that's given is the standard that ought to be deployed is the standard that was in place when the technology was deployed. And in fact, we're dealing with this in the storage rack industry right now. As you know, storage racks, if well maintained, can be used for 20, 30, 40 years. The standard gets updated every 5 to 10. Does the enterprise then have an obligation to go through a complete redesign or recalculation of the structural capability of the storage rack? No. Unless they do a major modification or a revision or move things around or physically move the rack or do something else. So if there's a case that a technology has been deployed and the enterprise is comfortable with the way in which it's working, it's doing its thing, it's functioning, you're not making modifications to it, it can continue to do its thing. But and then even if you periodically maintain it, bring it back to its original state, there's not a requirement to do an update to bring it up to compliance with a newer version of a standard, if a newer version of the standard exists, or if, in the answer to your question, if the standard now exists. A company is certainly welcome to do so if they so choose, but they might not be obligated to it. But if you are making a renovation or a modification to it, so if you're putting in airbags in your 68 Mustang, you want to make sure those airbags work. So at that point, you'll want to make sure that if you are bringing things into compliance with a newer version of a standard, that you are indeed meeting the requirements of that standard. But ultimately, it's up to the enterprise to make that decision, knowing that those are the rule of thumb options available to them.
A lot of great insight there. Thanks, Pat. And I hope we can agree. Leave the Mustang alone, right? Leave the Mustang.
Yeah.
Leave it alone.
Leave the Mustang alone. Yeah.
The mobile automation, do what you think is best, but the Mustang. What are some questions that a buyer, for a prospective buyer for mobile automation, should ask their, say, vendors with respect to their compliance with standards and their approach to safety?
That's a bit of a tricky question for me to answer, but I jotted down some things more like the things a customer ought to be considering if they're considering automation. And I think we've hit upon most of, if not all of these. Understand your processes and remember the verbs. Know that the actions that need to be done are some of the challenging areas when it comes to standards compliance. Feel free to ask questions. Again, another plug for the association, but go to the trade show. Go to ProMat, go to Modex, and in fact, we've got a third show that we've just announced. So in 2028, if you're on the West Coast, we're going to be in Las Vegas in the fall of 2028. So learn more about what you might know, or what, affirm what you know and know what you don't know. Getting involved with associations and going to shows, going to events can be a great way to educate yourself. Another thing that is a bit of a personal pet peeve for me is when companies treat everything they do as confidential business information. it's really, really hard to get the answers to some of the questions you need if you refuse to let your vendors know what you're doing in the first place. So I think companies need to be somewhat careful or comfortable with letting some of their guard down so that their integrator, their vendor network can help them customize the right solution for them. Know also that there are lots of right answers in when it comes to the automation space. So there's a lot of right answers in the material handling space. Something that we didn't hit on. The movement can be done any number of different ways. We haven't even talked about conveyors, but like, there's lots of different things that you can do, and in the right application space, they'll all work. And I think being open to choosing the right type of solution for your enterprise, both for what you need today and what you think you might need tomorrow, is good. And then, I can't emphasize it enough. The risk assessment concept, and understanding the hierarchy of how you go through and identify your risk reduction measures, I think is just a really good framework on helping to identify what you need to do, and hitting upon all the different areas. So knowing that as well, and perhaps asking questions on who is going to lead us through the risk assessment process? Where are we going to do that? Who's going to be involved in it? What does it look like? What do we do with it once we're done? I think it's really a vastly important aspect to consider in the process.
And I have one final question for you, Pat. Looking toward the future, what are a few things that the industry should get right with respect to development of standards and safe deployment of mobile automation?
Well, going back to what I talked about early on, we're still relatively early in this. I think in a lot of cases, we mostly are getting it right. Another thing I tend to see in the material handling space is nobody wants to be first, but everybody wants to be second. So, going through a deployment, the first one's always going to be tricky. Going through that process is going to be a challenge, but we learn so much about the things gone right, the things gone wrong when we make that effort, when we make those mistakes, when we correct those mistakes, that the second deployment and subsequent deployments, we get it right the more often we do things. Also, in the standard space, just being aware that you don't have to, or that compliance to a standard isn't necessarily an exercise of going through a checklist and saying, these are the 15 standards I need to utilize. If I check the box on all 15, I am done. I am safe. I am, everything is perfect, and away I go. The standards really kind of help define the framework or the playing field, and ultimately the strategy on the standards that you're going to rely upon, and in terms of your deployment, acknowledging the standards that you say, I'm not going to comply with this standard because I'm complying with this standard instead, and there's potential for contradiction in the two. I'm going to choose this one. It's going to be suitable for my application, and we're going to make sure that we comply with that one. But doing those types of things, I think the industry will continue to do those things, and will continue to get it right. And really, even having the opportunity to do something like this with Rockridge is helpful as well. Sometimes I'm not let out of my my cage too much. So, giving me the opportunity to help promote the message, is something that I appreciate as well. So, before you thank me, I'll thank you for this opportunity.
Yeah, well, the information is invaluable, really. Something I think all of our listeners are going to really enjoy. So, thanks so much for coming on the automation journey, Pat. Really do appreciate your time.
Yeah, you're welcome. It's been a lot of fun.
This conversation really reframes what it means to deploy mobile automation safely. Standards matter, and compliance matters, but they are only the starting point. The deeper work is understanding the specific risks of the application, maintaining discipline around restricted areas, preparing the people who will work around the equipment, and treating safety as something that has to be managed every day after the system goes live. The core takeaway is this. If you are introducing mobile automation, the question is not only whether the system meets the applicable requirements, it is whether your facility is truly ready to operate differently. That means understanding what changes on the floor, who owns each part of the safety process, and how your team will keep that process alive over time. If you know an operations director, plant manager, safety leader, or project sponsor who is considering their first mobile automation project, send them this episode. It is a valuable conversation to hear before that first vendor meeting. If today's episode got you thinking, you won't want to miss what's next. Coming up, we're going deeper into the technology side of safe automation, the sensors, systems, and design decisions that don't make it into the brochure. We've also got an episode on why most automation projects fail before they even start, the process gaps, the system questions, and the foundational work that separates deployments that deliver from ones that disappoint. Plus, we're tackling the project management discipline behind complex, multi-system deployments. Make sure you like and subscribe so you don't miss it, and I'll see you on the next episode of The Automation Journey.